Hi everyone. So in the beginning of the video, you might have noticed that this boulder right here gathers up with snow over time. And it's not only the textures themselves that are blending, it's also the vertices that are getting displaced upward. And with this one property, we can make how much snow we actually want. So let's see how to make this whole shader right here in an isolated environment. And then we can get back to this scene to see how to animate this property in Sequencer, which is pretty straightforward. In my new scene, this is how the end result looks like. The majority of the magic comes from the textures themselves. I have Quixel textures in use here, some simple dirt tracks texture that has a height map, which is very important for that not uniform blending. And then a mask map. In red channel, there's metallic, which does not exist here since it's dirt. In green channel, here it's ambient occlusion that is stored. Blue channel does not store anything because it's detail. We won't be using that. And in the alpha channel, we store smoothness values. And it's a pretty similar story for snow. All we need actually is a snow albedo texture and a snow normal. Mask map is not really necessary, but I will use it anyway for consistency. It does not really store anything except the alpha channel, which is not really visible, but it's not entirely, it doesn't show as entirely not smooth. There's a bit of smoothness stored in here. So yeah, we can hide our end result, go into our new folder, make sure we have all these textures set up, create a new shader graph. I'll be using HDRP, so I'll make a new shader graph, lit shader. I'll call it new snow maybe. And I also create a new empty material so I know what I'm doing. Then add the same sphere into the scene so we can compare everything later. Assign the material, and I'm opening the shader graph. So the first thing we want to do would be set up the properties that we need. So what we'll need is a base color. Then, oh yeah, so this will be base color map because I created texture to D. And then for base color, we create a color property. We can immediately set the base color to pure white, alpha 100, because it defaults to black. So it's mostly recreating our default lit shader at this point. A metallic value, which we can have set to 0, and also we can change the type to slider because we don't want values going above 1. Same story for smoothness. In this case, we can set default to 0.5 and also a slider. And then we might want normal intensity. And here, the reference is set to normal intensity. But in reality, if we want to change a shader from, let's say, HDRP lit to the snow shader, this wouldn't catch the references. So what we could do is check what is supposed to be the keyword to find the normal intensity value in the lit shader itself. And if we search for lit in the search box, go into packages, select our lit shader, we can see all the keywords that we need here. And in this case, normal intensity that I am naming, and I need this property is called normal scale. So this is what we will name this reference. And then let's continue creating the rest of our maps. And we also want tiling. Okay, we have our properties created. Now we can check. Now we can set up our actual nodes. So let's start with base color. The most basic things, we need to sample this texture. And we also want to multiply by our color in case we want a bit of changes in our mesh changer. Also, we have to remember our tiling. So I create a tiling and offset node, assign our tiling property, and what we will do is that we need to blend this result with our snow result. And for that, we can use a Lerp node. So how it works right now, 0 means the result is completely black, and 1 means it's completely white. And then if I change t value, which we will assign a blend mask later, you can see how it changes from one result to another. So this will be our main driver. We can assign our albedo setup into A, and then we can recreate new properties for snow and then assign everything into B. So what I will do is create a new category for all the snow properties. We need one called snow normal intensity, snow mass map. We could use smoothness instead, but for me, this will be fine. We also might want to introduce snow tiling property, but this time I will create it as a float. And the reason we are doing it like this is because for snow, I'm going to use triplanar projection instead of sample texture 2D because we don't really care about mesh UVs. It will be just more straightforward to use triplanar. Otherwise, we could also use planar projections since the snow will be mostly showing from top as well. But since that will create a bit of stretching on the sides, triplanar will be doing just fine. But for performance sake, I suppose planar should be better. So continuing with this, I assign snow albedo into our triplanar projection. And then we can simply lerp our snow into P section and already assign our end result into base color. Actually, maybe I'm not going to assign right now because we need this process copied for normals and for mask map. So let's do that. I'm going to jump on normal part. So what we need to care about is that type should be set to normal instead of default. Same for snow. And since this is normal, we don't need a color anymore. Let's delete our albedo properties and change it with normal textures. Now we have normal intensity properties that we should utilize here as well. And for that, there's normal strength node. So let's plug that. And into our strength input, let's put our intensity properties. Okay. And now the last part is mask maps. So now we don't need normals. Now we need to lerp individual channels. Since this is metallic, we have to multiply our results with our created metallic property. Snow is not metallic, so we do not need to do that. Then our ambient occlusion could go directly since we did not create a property for that. Detail map, mask map can be skipped since we are not using that. And then for smoothness, we multiply by our smoothness property. And we can expand on smoothness later as well. And same for triplanar, but since it's only vector 4 output, we need to split these channels and plug everything into B parts. So our metallic, our ambient occlusion, and our smoothness. All right. So we can group all these nodes and call them Lerp textures. All right. So our Lerp based textures are set up. Now we could actually plug in all those Lerp results into our inputs of fragment shader so we can make sure that everything works correctly. So base color into base color, our normal blending into normal, red channel into metallic, then green channel into ambient occlusion, and finally smoothness as an alpha channel. I'll bring this here so it could be somewhere in the middle. Now let's save our shader and let's get back to the menu. So this is the result we see. When we select our shader, we can see that it is because none of the textures are assigned. So we can do that. Let's assign our dirt. and then our snow. Now another problem is that we do not set tiling defaults. Now it's set to zeros, so we can select here 1 to 1. Snow normal intensity can be also 1, snow tiling 1. And let's do the same in the main shader. Our tiling property is 1, 1. Snow normal intensity should be 1 as well, and snow tiling 1. And that should be good. Now we can check this mysterious T property of Lerp, which will be our Lerp mask. So we can start from our base texture height map. Let's sample that one. And we don't see the preview, so we can also reference our texture so we can see better how it blends. Then we need a normal vector. And what this will help us to do is to get the direction of the snow. But first we need to tell where will be that direction, and for that we need a new property. I'll first make a new category for some extra snow controls. And I'll call, so we need not float, but we need vector free for our snow direction, and y will be default of 1. And for this to work, there's a magic function called dot product, which will get us our direction that we want. So since 1 is y and everything else is 0, it means all the snow pops up completely on top. And if I slowly change this x result to the sides, you can see the angle changes more upwards to the x result. What thing to note is that we do not want this blending to go above 1, otherwise bad things will happen. Snow can start glowing. We don't really want snow glowing, so for that we have a node called saturate, which clamps our result from 0 to 1. So what we can do now is multiply this snow accumulating on top node with our height map, and we immediately get this nice result. Nice in a way that its snow is not uniform anymore. So we need to tell how much snow will there be on our surface. And we need to create a new property again, call it snow intensity. I'll move it to snow controls. Snow intensity can be default of 1. Multiply again. And we can do additional thing, which would be snow remap. Let's see how that looks like first. So if I would plug in our end result into remap, I'll make output as -1 to 1, and I would change, let's say, y to something like that. You can see I get either way sharper or less saturated transition. And we can use that in cases where we want additional controls, how our transition part should be looking like. So I'll create a vector 2, call it snow remap, and I'll make default values from -1 to 1, put it into the input, and we can leave it like that. So that's the blending part for the texture. Now we can plug everything into the Lerp. I'll double click on this node right here so we could plug everything more nicely. And yeah, let's just plug everything into the rest of the T input. Okay, now let's save the asset so we can see how our blending looks like right now. And yeah, so this is the result. Kind of grayish looking snow, but if we increase the intensity, you get this nicer looking blend. We can also verify that the direction is working and that the remap is also working, which also seems to be remapping the main texture too. So that is because we want to saturate our end result as well to clamp things to one. Otherwise, we go out of range. Let's resave the asset again. Okay, so now everything looks more normal. Okay, so that is the blending part of the texture. Let's group these nodes, call snow blend. And now we can move into displacement part. To start out with displacement, we can enable tessellation. To do that, in graph settings, in lit material, there's a tessellation option in surface options. And what this will do is it will allow us to have additional geometry on our snow part, which will make our geometry less triangular, more smooth, less popping showing up, which helps a bit. So we can see that in the vertex section, if I drag up that vertex group, we can see that we have a tessellation factor and tessellation displacement inputs showing up. Yes, so we can recreate first our tessellation factor input. Let's just apply that tessellation factor directly into this node, and maybe I want to have that some random value like 20. It will be fine for now. And for the tessellation displacement, we want to start out with what we did here. So what we can do first is this section right here, we can make a subgraph. So we don't need to copy. So we can just copy and paste everything back. Because it's pretty repetitive. So snow, blend, subgraph. Let's wait until Unity finishes executing. We have our subgraph, and we might want to rename these two inputs right here. So vector 1 will be snow direction, and then vector 4 will be our height map. Save the graph. And then let's get back to our main graph. And we can copy everything here. So if we would try to plug this in right now into our tessellation displacement, you can see that it does not allow us to do that. And why is that? It is because we have a node that is not supported for the vertex part, which is sample texture 2D. It somehow cannot sample bitmaps. So for that, there is another node called sample texture 2D LOD, where we can tell which LOD to use. So 0 will be the highest value. We can check how it looks like in the texture viewer. So this is the number 0 bitmap, and when we go lower, it gets blurrier and the resolution gets way lower. Now back in our shader graph, we can assign that sample texture to DLOD into Heightmap. And now you can see that, boom, we can plug it in. Right. So this is the part where I'm going a bit experimental, and there might be a better way to do this. But I will be building on top of this snow blend subgraph to raise the to displace those vertices. So to do that, I will multiply everything again. So our snow subgraph with our direction, with my experiments, this kind of helps to get a more rounded snow displacement. And we multiply that with our snow intensity. And now the difference is that snow intensity is already used in snow blending as well. And we might want some other controller to control how much actual displacement is showing up. So we can create a new property called maybe height sensitivity. I'll leave it somewhere at the back, and default could be like 0.0025, maybe too much. Maybe I'll add another 0. Let's see how it goes. And I multiply again. Our snow intensity with our height sensitivity. All right, so our result is mostly black, which is what we want, since the height should be very subtle. And then another thing we could introduce is how much the snow curves, how spherical it is. So let's create a new property called snow curvature. We can set the mode to slider, and default could be like 0.8. Not too spherical, not too looking like a hill or something. Right, so we multiply our properties, and the thing is that the way this curvature property should work is that it reduces the intensity of our X and Y x and y of x and z. It reduces x and z sides of our snow. So for that, we need a combine node. And the snow curvature will control x and z. And what will remain the same will be y. Now we lost the normal vector node since we used a dot product on it. And without it, the displacement will not go along the normals. So we need to multiply again with normal vector world. And that should be it. Plug that into tessellation displacement. Let's see how that goes. Okay, so nothing is showing up right now because our intensity is quite low. If we increase it, you can see it showing up. But this this right here, it's showing too big of a line. This no intensity has to go to a crazy value to go up. So now it's more like experimenting to see what fits the most, what value. So I will make snow intensity like 30, height sensitivity, I will reduce it, and then snow remap I will set to like 3.5. And this is something that we might want. We can snow curvature adjusts, makes it more like a hill. We can cut out the end as well, like 0, 1. All right, not too bad looking. Now the problem is that the snow is very shiny. Let's investigate why is that happening. So our smoothness. Okay. So what we forgot to do is our mask map is set to normal in our base texture and the main texture, which messes up the result. So let's save the asset and check back the result. And yeah, that looks way better. Okay. So if we check how tessellation is happening in wireframe mode, you can see that the whole sphere is getting tessellated. There's a lot of geometry popping up, which might not be what we want. So we can optimize that. First of all, let's group this part. So we know this is snow blend displacement. That's how I'm going to call it. Okay. And tessellation factor, we can change it up a bit. So we do another normal vector world, so we know what to change. We are interested only in the top part. We can do a split. Take out the G channel, which is Y, and then let's do step. And that will cut out half of the sphere. If our edge is 0, multiply by tessellation factor, assign the end result, save the asset. And now let's check wireframe, and you can see that only the top is tessellated, the bottom is left out completely untouched. Right, so we got so far. Now we can add some extra subtle touches so that our snow doesn't look so solid. And what helps with that is changing material type to subsurface scattering. So a little bit of light can pass through. This will create additional inputs, also transmission, which is not really needed. Our shader will be quite simple. So what we are interested in is our diffusion profile and subsurface mask. So subsurface mask, we already have a mask, comes from our snow blend. We can just plug in that. And for the diffusion profile, we need to create one. So create rendering HDRP diffusion profile, and I'll call it new snow since I already had one created. And here we can change our scattering color. So for me, white is completely fine. Multiplier, I'll set to like 10. And the index of refraction should be 1.31. I think this is the actual index of refraction of ice, so that should work. And we can leave the rest of the properties untouched. Okay. So let's assign our diffusion profile into our shader. Save the asset. This does not require a new property created in the Blackboard. And you can see that it gives this pink color. Depending on the version you are at, it could be green. But the point is, if a color is like that, means diffusion profile is missing. So what you need to do is make sure diffusion profile is assigned. Assign in here. It will give you a button to fix, so it would be assigned in the project settings. If it does not, go to edit project settings, graphics, HDRP global settings, and you will have a list of diffusion profile assets that you can assign here. And now we can see that it's way more blurrier looking than what was before. What we can do is increase the snow normal intensity, so we can bring back a bit of that subtle detail. And we can also maybe increase the tiling of the snow. Or maybe not. It will be fine like 2 maybe. And for some extra touches, when we are looking like by the sun, so another thing, when tessellation is enabled, you can see these things cutting through too early. So for that, you can play with tessellation options to reduce that. I think the max displacement, making it larger, can help with that. So as I was saying, when sun is shining, you might see some crystals showing up on the sides. We can try to replicate that. So let's go back to our shader. And here in our smoothness section, let's create a noise. Simple noise will be fine. So with that, we need some extra properties. So we need to control what size are our glitters. And then I'll create a glitter size property. We can set that to some insane value like 1000. Assign it to scale. And we also want to set how intense those glitters are. So we need snow glitter intensity property. This could be a slider, and default value could be like 0.7 maybe. And then we have this noise, but it's way too frequent, so we need a remap. And here I can just for my case, some hard value is perfectly fine. So 0 0.6, 0 0.7 will do, and then I'll just multiply by our intensity. And we need to add this whole thing with what we add to be Lerp. So add that, and our first input is the split triplanar snow. And then assign to be Lerp. Okay, that should function properly. We can group again, call snow glitter, save the asset. And let's get back to our main view. So in our main view, you can see that glitter scale is not enough. We can increase that with one extra zero. Now we have a bunch of these small dots showing up, which is fine when you look from the top. And yeah, that is pretty much it. Now, yeah, we can change the lighting, maybe see how it is. Bunch of things we can play. If we don't like how much diffusion we get, we can increase the value. But for me, this will be fine. We can increase the normal, like that. But yeah, that's the end result. Let's see how when we change intensity, what happens. And it slowly blends like this. Since we have a high remap set, the blending is a bit more sharp. But yeah, now it looks better. And yeah, for our end result, we can see how we can animate this property in Sequencer. Right, so back at our main project, let's see how to animate that in Sequencer. Let's create a new empty game object. I will call it timeline. Make sure you have sequencer window open from window sequencing timeline. I have it here. And for our new game object selected, just create a new asset. I already have one, so I'll just replace it. And we can add an animation track. Also, what I want to do is, for me, I don't care about frames, I care about seconds, so I'll change this gear icon here, and I will also lock the timeline. So when I am animating a mesh, it will not, timeline will not get deselected. So my main mesh that contains now is called the main rock. I'm attaching that. I press the start recording button and I select my main rock. So for first frame, I select snow intensity to be 0, around 10 seconds it can still be 0, so I nudge this intensity input a bit, and then until 30 seconds it always increases, just like that. And then I deselect record button, enter play mode, and let's see how it looks. That is it. I hope you guys enjoyed the video. If you have any questions, please comment. If you have any suggestions how to improve the snow shader, also let me know. Thanks for watching.